Today we're going to be talking about dividing polynomials, and we're going to look at two different cases that we might encounter. So one is dividing by a monomial, meaning by a single term, or by one term. And when we're only dividing by a monomial, we really just want to fall back into properties of exponents. So similar when like I have an equation, okay, if I have an equation and I wanted to rewrite in y equals, well, I'd subtract 6x, and then I'd divide by 3. And we know that these terms that are connected with addition, that I'm going to divide each of them separately by 3 and get negative 2x and positive 6. Okay, we've done that before. So if I have something like 3x to the 5th plus 10x to the 4th plus 2x, and I divide by 4x, okay, by a single term. Well, I really just want to take each term, just like here, each term and divide separately. And I could even rewrite it as like 3x to the 5th over 4x plus 10x to the 4th over 4x plus 2x over 4x. So each term I'm going to divide individually by 4x. And we know that our properties of exponents, that when we divide, we subtract exponents. And so for my first term here, I'm going to have 3/4, and then 5 subtract 1 is going to give me x to the 4th, plus 10/4 I can reduce to 5/2, and 4 subtract 1 gives me x cubed. 2/4, I'm not going to put that in, equals 1/2, and x over x is just going to cancel. Okay, so now I've divided each term separately by that 4x, and for my variables, I'm using my properties of exponents. So we have a few examples here. First one, so same idea. Each term gets divided by 6x, and so for my integers, I'm just reducing. 12/6 gives me 2. X squared over x, subtracting exponents, gives me x to the 1st. 6 over 6 gives me 1, and x over x is just going to cancel, so I'm just going to be left with 1 there. Dividing each term separately. And sometimes it's written like this. So here I have a binomial divided by a monomial. So I could rewrite it if I wanted it underneath. Okay, same meaning, it's just divide by 5m squared means I'm dividing each term by 5m squared. I'm going to rewrite this one. I'm taking the first term and I'm dividing by 5m squared. And I'm taking the second term and I'm dividing by 5m squared. Okay, so I can always break it apart if that's going to make it just easier visually to see what's happening. So 5 over 5 is just 1 or cancels out. M to the 5th over m squared subtracting gives me m cubed. 10 over 5 gives me 2. 3 over 2 subtracting leaves me with 1m. Okay, just dividing by a single term is really properties of exponents for each term along the way. Now, I'm not always going to have positive exponents here. So, for example, on the next one, so individually dividing each of these terms by 4a cubed. So looking at the first term, 16 divided by 4 is going to give me 4. And a to the 5th divided by a cubed, subtracting, gives me a squared. Subtract, looking at my middle term now, 12 divided by 4, negative 12 divided by 4 is going to give me negative 3. A to the 4th divided by a cubed, subtracting gives me a to the 1st. Now looking at the last term, 8 divided by 4 is going to give me 2. A squared over a cubed would leave me with 1a in the denominator. So some of my terms may look like this, where my variable is going to end up in the denominator of that term. So now why don't you go ahead and do this last one on your own and then continue the video and compare and see how you did. Okay, so here's kind of, I haven't circled it yet because I'm not quite done. I have 7/4, no longer negative, 3 take away 1 gives me 2, -3, subtracting exponents, and -4x over -4x is 1. Now, the reason I didn't circle this is we always want, when we do operations with polynomials, whether we're adding, subtracting, multiplying, or dividing, we want our answer in standard form. So I'm going to rearrange this so that it goes largest exponent to smallest before I give my final answer. Okay. So that's one piece of division, dividing by a single term. Really, it's just properties of exponents. And now comes the tricky one, which is long division. So before we get into polynomial long division, we're going to refresh our memory on what long division really even means. So if I have 2,580 and I want to divide by 4, then I could do that using long division. And I just kind of want to talk through what we do when we do long division. So first I can't go into 2, so I go to 25, just 25. And I'm saying, well, how many times can I divide 4 into 25? And I could fit 6 factors of 4 into 25. So what I'm doing there is division. I'm taking that 6 and I'm putting it up top, saying, well, it fits into 25 6 times. And then I'm saying because 6 times 4 is 24. And I subtract that 24 out, leaving me with 1, and bring down the next term. Divide, multiply, subtract, bring down. That's the loop that we go through. So now here I'm dividing in 4. How many times does 4 fit into 18? 4 times. Then I take that 4 and I multiply it by what's out front, 16. I subtract those 4 factors out, leaving me with 2, and I bring down the next value. And so now I have 20, and 4 divides into 20 evenly 5 times. 4 times 5 is 20. Subtract that, leaves me with no remainder, divides in evenly. So this would be 645. Some people remember this with a little sentence, this little pattern that we go through with long division. I've heard a lot of does McDonald's serve burgers as what's used to remember the loop used in long division. A lot of students make up things with Mrs. Sawyer. Does Mrs. Sawyer bark? Does Mrs. Sawyer bake? Does Mrs. Sawyer bite? Whatever works for you, so that you can remember this pattern, because it's the same, the long division is the same when we do polynomials. It's the same rotation of divide, then I multiply it, I subtract it, I bring down. I divide that, I multiply it, I subtract it, I bring down. So let's look at another one with just numbers, and then we'll jump into our polynomials. So 345 divided by 4. 4 goes into going to 34. 4 goes into 34 8 times. Okay, that's the divide piece. Multiply 8 and 4 gives me 32. Subtract that gives me 2. Bring down. 4 goes into 25 6 times. 6 times 4 is 24. Subtract that is 1. I have nothing else to bring down. This is what we call a remainder. Okay, so in our problem, we have a remainder, meaning it doesn't divide in evenly, there's a decimal going on there. So the way that we write our answer, and so this is called our, let's give some vocab here, our quotient. Okay, the result of a division problem is a quotient. This is called our divisor. And the way we write our answer, well, if we just have a quotient, then we have our quotient. If we have our quotient and a remainder, we write the quotient and the remainder over the divisor. So what this means is it goes in 86 times, and then I have 1/4 remaining. And the 1/4 is coming from the remainder over the divisor. So our answer is always the quotient plus the remainder over the divisor. That's also true when we have remainders or this is 86.25 if I wrote the decimal version. Even when we do our polynomials, same idea. If I have a remainder, I'm writing what was my answer plus the remainder over the divisor. Okay, so now let's dive into some polynomial long division. So here's my divisor, just like here, the term that comes second, that's what I'm dividing in. So I have 2x plus 3 out front is being divided into 8x cubed minus 4x squared minus 14x plus 15. And what I do is I put a little squiggly line and I'm going to do my work over here. We're going to follow the same pattern. Divide, multiply, subtract, bring down. So what we're dividing, okay, just like we took the first amount we could look at here and divided in 4 and then went from there, we're taking our first term and we divide it by the leading term. So we have to write things in standard form. Also, that's important, by our leading term out front. So this first step of division, I'm saying, well, how does 2x divide into 8x cubed? And we're using properties of exponents here. So this would become 4 subtracting exponents x squared. So if I divide 2x into this first term, I have 4x squared. Now this other term that's here doesn't get lost because now, okay, just like up above, so let me show you this one. We said 6, and we said, well, 6 times what's out front is 24. We're going to do the same thing. We're going to take 4x squared and multiply it by what's out front. So I usually kind of write that out over here. I'm going to multiply that through by the divisor, and that's what I'm going to write here. So 4x squared times 2x would give me 8x cubed, 4x squared times 3 is going to give me 12x squared. Okay, so I've taken, just like here, taken the 6 multiplied by 4, I've taken this 4x squared, multiplied it through to 2x plus 3. Now the next step is to subtract. So let me write what we got here, 8x cubed plus 2x squared. So going back to polynomials earlier, if I subtract this, remember that means that that negative needs to go through, and I wouldn't normally write all of this work out over here. Oops. That negative, that subtraction hits any term in that polynomial. So when we get to this subtract step, I just go through and change all signs all the way across. Let me read today what we've already done. Dividing into the first term, taking the result of that division, we multiplied through by what's out front. Now we subtract, change all our signs. And if we're doing this correctly, that first term should cancel out. And it's going to leave me with -4 and -12x squared, or -16x squared. Bring down my next term. That's the last step. I'm going to separate this off. Now I just loop back to the beginning. So I'm going to take my first term, my new first term, which is -16x squared, and divide it by the 2x out front, first term out front, which gives me -8x. Division part, that's what goes in our quotient. I'm going to take that -8x and multiply it through by our divisor, which would -8x times 2x is going to give me -16x squared. -8x times 3 is going to give me -24x. And I subtract, which means a negative's distributing through those terms. It's changing all of our signs. Look, our first term canceled. This is going to leave me with 10x and bring down my next term, which is 15. And now I go through the process again. Okay, I just brought down, I go back to divide. First term, my first term, I'm now looking at 10x. Divide by first term out front. X is canceled. 10 divided by 2 is 5. +5 is the next term in my quotient. Take this 5, and it's going to get multiplied through to 2x plus 3, which would give me 10x plus 15. So divided, I multiplied, subtract, boom, boom, change all signs. And now I'm at the end. In this case, no remainder, everything canceled out. So 2x plus 3 divides evenly into this polynomial, which is actually something that becomes more and more important the further you get in math. This is a factor of this polynomial, it divides out evenly. So my answer is 4x squared minus 8x plus 5. Okay, let's look at another one. Flip this page when you're ready. You can pause the video if you need to write down some more stuff. Okay. Okay, so on this next one important piece that we want to point out here is that we need our divisor and what we're dividing into to be in standard form. So here's my divisor, 2x subtract 1. That's in standard form. Now this is not, so I'm going to rewrite it. Largest exponent first. Okay, so always keeping it in standard form. And divide, multiply, subtract, bring down. So first term, dividing into that first term, 4x cubed divided by 2x gives me 2x squared. 2x squared. Now multiply that 2x squared through by what's out front. So I can write that over here, or I can just kind of visually bring that out and multiply it through 4x cubed minus 2x squared. Now subtract. Boom, boom. Subtraction changes all signs. Those are going to cancel. It's going to give me negative 2x squared. Bring down the 5x. Repeat the cycle. Divide. So the division, negative 2x squared divided by 2x gives me negative x. Negative 2 over 2 is negative 1. X squared over x. Take that negative x and multiply out front, which would give me negative 2x squared plus 1x. Negative x times negative 1. Subtract changes all of our signs. These cancel. And I have 4x, bring down minus 8. First term, so 4x divided by 2x, right? Here's my leading term. Gives me, these x's cancel, just 2 plus 2. Take 2 and multiply it through by what's out front would give me 4x minus 2. Subtract. These cancel. Negative 8, positive 2 gives me negative 6. This is now my remainder. Okay, I know that because I can no longer divide, like my exponent value here is greater than here, so I stop at that point. Okay, anytime that my exponent of my divisor is greater than what my leading term is here, that becomes my remainder for these long division problems. So my final answer here, the way that I write my answer, I'm going to rewrite that here, is take the quotient plus the remainder over the divisor. So this is my quotient. This is my divisor that I'm dividing by, and here's my remainder. So my final answer, I don't really have a ton of space here, would be 2x squared minus x plus 2. And because this is negative, instead of plus 6, I'm going to have negative 6 over 2x minus 1. And there's my final answer. I could have also written it like this, 2x squared minus x plus 2. If I did write plus, I could have written negative 6 over 2x minus 1. That also works. Okay, but here's my quotient. Here's my remainder. I have no space. Remainder, and here's my divisor. Okay, so anytime we have a remainder, we need to rewrite our problem, including the remainder over the divisor. Okay, I would like for you to try to go through the process for the next one on your own before continuing the video. So pause the video and try this one on your own, and then you can play the video and I'll still talk through it, but that way you can check your work. Okay, go ahead and pause. All right, so my divisor here is 3w subtract 2, being divided into 9w squared plus 6w plus 10. Little workspace, divide, multiply, subtract, bring down. My first term is 9w squared. I'm going to take that 9w squared and divide by my first term in my divisor, which gives me 3w. Take that 3w and multiply through out front, which would give me 9w squared minus 6w. Subtract, it's going to change all of our signs. These cancel, gives me 12w plus 10. Take my new leading term of 12w and divide in 3w. W's cancel and it gives me 4. Take that 4, multiply throughout front, 12w minus 8. Subtract, changing my signs, these cancel, and gives me a remainder of 18. So my final answer here would be 3w plus 4 plus 18 over 3w minus 2. Quotient, remainder over divisor. Okay, so before you get kind of more practice with this and start working on some review work, we need to talk about some things we need to consider. So one is if we divide into a polynomial with missing terms, meaning I have an x cubed, but I have no x squared and I have no x. When that happens, what I want you to do is include all degrees all the way down. So if it starts at x cubed, I'm going to include an x squared, and I'm going to include an x, and then I have my constant term. And that way, as I do my division, what you'll see is that we may need these middle terms when I multiply through and write what's underneath. Okay, so when I'm dividing into a polynomial with missing terms, include all degree terms with a 0 coefficient. Okay, so I'm going to still have every single degree going down to my constant term, just going to have 0 x squareds and 0x here. Same procedure, divide, multiply, subtract, bring down. So my first leading term, and you're going to see why we put those zeros there in a minute. My first leading term is x cubed. Dividing x into it gives me x squared. I'm going to take that x squared and multiply through out front, which would give me x cubed minus x squared. And notice, like up above, we were lining up like terms, kind of just naturally was happening. So same idea here, I'm lining up like terms, and what ends up happening, so now subtract, change all of our signs, these will cancel, and even though my original problem didn't have an x squared term, now, because of me multiplying that x squared through, now my leading term is going to be 1x squared. And I'll bring down to 0x. And I divide that x squared by x, giving me x. Multiplying that x through, I get x squared minus x. Subtract, okay, so these zeroed terms came into play during the division. Gives me 1x minus 1. Take that x, divide it by the x out front, gives me 1 for my last term. 1 times what's out front is x minus 1. Subtract, gives me a remainder of 0. That all cancels out. And here's my quotient. Okay, so dividing x minus 1 into x cubed minus 1, I actually end up with more terms here. And that's why those zeros are important. Okay, so I want you to, let me write the beginning for you. So x plus 4 being divided into, when I have x squared minus 5, I'm missing, it's not x squared, it's r. I'm missing the linear term here. So I'm going to add in 0r so that I have it for when I go through that divide, multiply, subtract, bring down. I have a place for those like terms to go. Okay, so pause the video, try that one. and then replay the video and I'll kind of talk through what I did. So leading term is r squared divided by r gives me r. Taking that r and multiplying by out front is r squared plus 4r. Subtract, so that 0r is coming into play right now. It's going to give me negative 4r, bring down the minus 5. Leading term of negative 4r divided by r gives me negative 4. Take that negative 4 right in our quotient, multiply it out front. Negative 4r minus 16. Subtract. These cancel, and it's going to leave me with 11 for a remainder. So my final answer will be r minus 4 plus 11 over r plus 4. Okay, quotient plus remainder over divisor. Now, when we're dividing by something that has missing terms, I don't need to, do not add the 0 terms in. But we do want to look at what happens there. And so what happens is we end up skipping happens when dividing. And what I mean by that, so now I have all my terms here, 4, 3, 2, 1, that's fine. But what my divisor is x squared plus 1, meaning I'm missing my x term out front. And so it does look a little different in terms of how the work kind of pans out when that happens. It's not as important. I don't need to worry about having a 0 there like I do when it's what I'm dividing into is missing a term. Okay, but divide, multiply, subtract, bring down. So first term is x to the 4th, dividing by x squared. That gives me x squared. Taking that x squared, multiplying it through, x squared times x squared gives me x to the 4th. X squared times 1 is going to give me 1x squared, which I'm going to write underneath. So that's what the skipping I mean. Like you're going to end up with a gap for your subtraction. So now subtract, change all of our signs. These will cancel. And so I'm actually going to bring down the 2x cubed, and what will be combined is here. It'll become 2x cubed plus x squared. So I have to bring down this term, subtract here, and I'll still bring down the next term because I'll still need 3 terms. You see how now I'm looking at 3 terms instead of just the 2? Okay, so I'm still going to have a skip again. Okay, so that's just really important to note, like that's okay. And I just don't lose that term that was skipped over. Now my leading term is 2x cubed. Divide that by x squared is 2x. Taking that 2x and multiplying out front, that's going to give me 2x cubed. 2x times 1 is 2x. So again, making sure I write it underneath the correct like term. Subtract, these cancel, so that term that was skipped ends up out front. And then negative 3x, bring down the negative 1. X squared divided by x squared gives me 1. Multiplying that through just gives me x squared plus 1. Subtract. And this will cancel, and will that cancel? No, it doesn't, right? It was plus 1 minus 1, so that doesn't cancel. Gives me negative 3x minus 2. Now, because I've now added a degree that's less than my divisor's leading degree, this is my remainder. So my answer here is x squared plus 2x plus 1 plus negative 3x minus 2 over my divisor, x squared plus 1, remainder over divisor. Okay, so it's a little funky when that divisor is missing a term. Weird stuff kind of feels weird while we're doing that divide, multiply, subtract, bring down, but it's doable. Okay? Just kind of give you an example of that.